Hi, welcome to the 310 project demonstration. In this project, we built a DTMF tone detector. The goal in this project was, given a sample wave file, we had to decode the numbers that are represented. We had two types of processing in this project. One's the offline and the other one is real time. In offline signal processing, the signal was processed altogether and the final output numbers were displayed. And in real-time processing, the numbers were displayed one at a time, and signal processing was as and when signal processing was done. So for this demonstration, we're just going to go over some sample files. In our real-time detection, in our demonstration, the thing has sped up because of time constraints. So Ron, can you start off with no noise wave file?
Okay.
And as you can see, it outputted the right number in both the real-time and offline detection. Next, we're going to go over a medium noise file, which is 0.61 SNR.
Got it.
And again, it outputs the right numbers in both the graphs. And next, we're going to go over high noise, which is 0.1 SNR. And yeah, it outputs the right values for this as well. I'm going to hand it over to Ron to go over edge detection.
Okay, so in the edge detection sub-VI, essentially what's happening here is it takes the full unfiltered signal, filters out all the values greater than 0.75, saves those indices in the array by use of shift registers. And then it'll then take the cumulative difference of the array of indices. And then when it detects a large change, like greater than 200 in that cumulative difference, that means a edge was detected. And so that specific indice is going to be saved into another array such that the output of the sub-VI is all the edge indices of the full signal. So I'm going to head over to the main portion. So with DTMF and DTMF online, essentially the structure of them is a little different, but the way they filter out the signals is essentially the same. So I will just head over here for DTMF here. So with DTMF, this portion here is essentially taking the edge indexes and chopping up the signal into individual portions for both real-time and offline. And Harpreet will go over the number filtering here.
Okay, so for the filtration part, we have used a bandpass filter with plus or minus 10 cutoff frequency. And then, for example, if form filter 1 and filter 2 is comparing its value with 0.4, comparing the maximum value with 0.4. If it's true, it will pass true to from the K structure. You can see from 2, true, it will pass 1 to the string concatenation. But if it's false, it will pass the empty string. And then the string concatenation function will concatenate the whole output into one string, which will show as the output. Now I will pass in to Yash to conclude the project.
Yeah, as you can see, like all the features were implemented successfully. The DTMF tone detector was able to output all numbers with no noise levels, and also to medium noise levels, which had a signal to noise ratio of 0.61 and high noise ratios of 0.1 SNR values. And yeah, this concludes our demonstration. Thank you for watching.
Thank you.